Okay. Good morning, everybody. John Mansfield. I get a relatively small crowd here, but hopefully it'll keep you entertained. John Mansfield, I'm the Chief Digital Officer for GE Aviation. And Sean Moser runs product for the GE Aviation Digital Group. So we're going to kind of go through a little bit about GE Aviation, and our partnership with Microsoft. I mean, that's the reason we're here, is really talk about our partnership, why we picked Microsoft, and what we're getting out of the relationship. A little on GE Aviation. It's about a $35 billion company, about 50,000 employees worldwide. We own 70% of the commercial airline engine market globally, so we're fairly dominant in that space. We have a very large military presence as well. Probably about half of the military engines in the world are built by GE. We also have an avionics division, a BGA division, which is general aviation, more like Bombardiers and Gulfstreams, et cetera. In that division. We also have a 3D printing business, what we call Additive, which is part of the GE Aviation family. And then we have my organization, which is the software group. So we're the GE Aviation's digital group, is our definition. GE is about a 100-year-old company. We've been in commercial airlines from the very beginning. And actually, we started actually in the military. So we started making military engines way back, long before any of us were born. So go through that a little bit. Even within, just for a little context of my organization, we have basically four pieces to that organization. We have a connected aircraft piece, which is, and we just signed a deal with Bombardier last week at NBAA, or 2 weeks ago. And basically, we're going to be able to offer in-flight communications services to all the Bombardier aircraft. It's about 2,500 worldwide. So we're supplying the hardware, the software that runs on-prem. A lot of security things. We're working actually with the Microsoft team to make sure we have a very secure connected aircraft strategy. We have a software as a service business, and Sean's going to go through some of the details on that. We have a professional services organization and a data piece to our platform. And we're actually working on integrating our time series data with our structure like maintenance records, et cetera, into a common data repository on the Microsoft platform. Just within our software division, we have about 450 customers worldwide. We broke it into the majority, and Sean's going to go through the commercial airlines piece of it. With commercial airlines, military, lessors are a big customer for us. They own about 50% of the aircraft in the world are actually owned by lessors, not by the airlines themselves. Business and general aviation is another key piece, and then obviously the military. And I was delighted to see the Jedi win by the Azure team. So that really helps us with our story on the military front. Anything else I really want to touch there? I think that's good for that. Why did we partner with Microsoft? We decided 2 years ago as a team, and we looked at we did not want to be in the infrastructure business. We did not, that's not our core competency. We are domain experts in aviation. We want to focus all of our time on the analytics and the application layer. And Microsoft, I've known Microsoft a very long time, worked with the Azure team all the way back to 2009. So I knew the people here, I knew the relationships they have with their end customers, and having that trusted go-to-market partner was a big deal to us. Being able to actually go co-sell and support our customers together was probably the most important piece of the relationship that we really wanted to codify. So they have reach in all of our customers. So the 450 we have, all those customers are Microsoft customers as well. So there was a very tangible and rational reason to actually partner with them. So I'm going to turn it over to Sean. He's going to go through the commercial airlines piece.
Thanks. Hi, everybody. So I run the product portfolio for Aviation's digital group. We're going to talk about just one of those segments and a couple of those solutions and why we're using Microsoft, how that's helping us. Just a couple things about me. I'm new to aviation. I've only been with GE for a couple of years, but I like big problems, like big, hard, challenging problems, and I like mission critical, which I guess means I also I like pain. So there's nothing more mission critical though than sort of keeping people safe when they're suspended above the earth, right? And so that appealed greatly to me. And the big, hard, hairy problem part that gets you up and out of bed in the morning, we're going to kind of dive into here a little bit. How many people flew here, by the way? I'm assuming nobody walked, so we'll skip that part. Okay, so when you flew, while you were in the air, there were about 60,000 other human beings suspended above the earth at the exact same time you were. Okay, and on any given day, about 12 million people travel by air. There's tens of millions of packages get delivered by air. All of that travel covers about 13 billion miles, and it's done basically leveraging over 100,000 flights per day and using about 30,000 aircraft worldwide, 28,000, something like that, aircraft worldwide. That is today. That happens every day right now. So that's a good proxy for scale, or scale is a good proxy for complexity. You can see how this is kind of like okay, there's a lot of moving parts here, and so on. If I roll the clock forward a little bit, we take all those numbers and we increase them by 25 to 50%. So what you'll see that's really interesting, maybe kind of starting from the right, is we're going to increase the global fleet by about 25%. But we're going to nearly double the number of miles we fly with those planes, and nearly double the number of flights we do with those planes. So you're going to try and jam even more capacity out of each plane. And we're adding new planes, but there's a whole lot of old planes that are still flying. And there's a huge amount of variance in those planes. We'll talk about that in a little bit. So this challenge not only is a challenge just from hey, how do I manage all this and make all this happen, but this also creates interesting loads on the people that have to do this job. There's a shortage of pilots in the world. That doesn't get easier when you put these numbers up. You've got a trained crew, you've got ground people, you've got thousands and thousands and thousands of people worldwide that make this happen every day, and there's not going to be a whole lot more of them trying to do this job. So there's a lot in here. Now, there's some things that we can't move, right? So one thing that cannot move is safety. Safety is an immovable object for us. It's a zero tolerance thing. We are in the safest time in aviation's history right now, and we are not going to let that change. We want that to get even better every single day. But we are doing that basically within a flat run rate. Amber alert. We're doing that basically within a flat run rate. And there is no airline in the world that does not want to improve the service that every single one of you got when you flew. So how do you do that? How do you increase capacity, increase the number of things you're doing on a daily basis with basically the same resource you've got now and do it with better service? So what we do is we look for opportunities to optimize. So GE, just as a case study within ourselves, GE Aviation has done something that's, I think a lot of you could probably appreciate. As you can imagine, it's a pretty expensive thing to make a new engine. So inventing a new engine is really expensive, really hard, takes a long time. If you want to have fun, go on YouTube and look at how we test the engines. It's pretty awesome. We have machines that make all different sizes of hail that we spray into the engines. We launch frozen turkeys into them. We do all kinds of really cool stuff to figure out what happens when they break. And that's expensive. Every time you do that, that's a lot of money that you're blowing up. So to do that, you've got to kind of recapture some money, or you're going to increase a lot of spend. But we couldn't do that as GE Aviation. And the interesting thing is, we compete in every engine segment. John talked about how much of the market we own. Every 2 seconds or so, a GE-powered aircraft takes off. And we do everything from small business jets to the single-aisle planes that most of you flew, to the big, giant double-aisle planes that fly long-haul flights, to jet aircraft, fighter jets, to small helicopters, to heavy lift. I mean, everything. We do all of it. And we have refreshed nearly every single engine in our portfolio over the last several years. That's expensive. That's really hard. We've outspent all our competitors. To do that, we've basically taken hundreds of millions of dollars out of our own cost every year using digital technologies. We've been doing digital within ourselves for about 2 decades. We then extended that to our customers. So doing the same thing for our customers that we do for us, we look for opportunities. You can see some big chunky ones up here. The two things that drive any commercial airline is their personnel, their crew, and then the other one is fuel. Crew are talented, well-trained people. We don't want to reduce costs there. We want to make their lives easier. But fuel, we absolutely want to reduce the cost of, and everybody is doing a fuel program of some kind. We help there. But the other two, and I'm going to spend a little more time on those, is unplanned maintenance. So when a plane can't fly the mission it was supposed to fly when it was supposed to do it, that's expensive. That's really, really expensive, and it's painful. And then network disruption. So when the plan for the day can't be executed the way you want it to, for whatever reason, because that plane couldn't fly, or because of weather, or because of something. Those two things are massively painful. And so we're gonna look at those. So that's about $75 billion if you add all that up on the slide. But not all of that can be addressed through digital, right? There's rules and laws and regulations and physical things you just can't change with software, as much as I'd love to. We can't. But there's about a third of that we can. And so we hunt for that, and we go after that. To do that, we basically need data. So there's two places we find our data. Data being kind of the oxygen for all these solutions. One is in the enterprise itself. That's highly siloed and highly fragmented. It lives all over the place. And then the other is on the aircraft. So let's talk about those two challenges real quick. Within the silos, you've got all these different departments, so the data is compartmentalized across all those. And then on the plane, which is our edge device, think of it as a giant edge device, there's a huge amount of variance. So how many people knew what plane they flew on? Anybody know it? Call one out. What'd you fly on? Okay, so 787-800 is a pretty new plane. That plane has about 20,000 or so sensors on it. Who flew something else, a single aisle? What'd you fly? A 737. So a 737, let's call it reasonably fresh version, so a 600, a 700 model plane. That is only going to have a couple thousand sensors. So you got to, just within those two planes alone, you can see like a massive amount of disparity. The engine on that 737, we're probably capturing about 2,000 data points per second, something like that. It depends on the version, but let's call it that. On your 787, we're capturing about 6,000 or 7,000 data points per second. The new engine that we just released at Paris Air Show is doing over 10,000 data points per second. So you can see like the orders of change. And so in that 40,000 plane fleet that we're going to have flying, you're going to have all this disparity. So what we do is we make a box we put on that plane. Think of it as like microservers with partitions, with containers, and we can run secure stuff on that, but we also can run our own analytics and applications on that. So Microsoft helps us, one, break down the silos inside the enterprise, two, bring in external data from public sources, and three, with the edge partitioning and edge management and deploying those analytics and pulling all that data back. So there's a huge amount of scale stuff. And we think that we can increase then from a really pathetic 1.5% of the data captured to about 25%. So what do you do with that data? You've got that data now. We actually have proven that what we can do when we have that data is we can find real returns. So I can do things like we can reduce the cost for available seat mile, which is how the airlines measure their cost, by about 10%, which is a lot for them. That's a huge amount of savings. We also can convert some amount of those unplanned events to planned events. Each one of those you convert, you reduce its cost by as much as 90%. By doing that, just that one conversion step of catching it before it happened, not when it happened. And then passenger experience, we've been able to improve on-time performance for the airlines that we work with by a significant amount, which improves your experience overall. So how do we do that? Basically, the way we do that is, one, we are a trusted custodian of our customers' data. So our customers generate a lot of data. We don't capture all of it, but what we do capture is pretty important. So we have about 46,000 years of full flight data that we store for our customers all over the world. We have hundreds and hundreds and hundreds and hundreds of millions of maintenance records that we preserve for our customers all over the world. We have thousands of airline personnel, thousands of pilots, tens of thousands of crew who use our tools every day. But we could do so much better. That's a small amount. There's so much more to go do. We apply 100 years of domain expertise, as John said, to that. What that is not just engines, though. We understand how the machines work, but we also understand how they're used. We know how engines work, how planes work, how airlines work. We have people from all of those industries back into us, and we leverage that expertise across all of these things. So we know what data matters, we know how to find it, we know where to get it, and then we know what to derive from that data. But doing that at scale, doing that in a repeatable way, because we've been doing this for 2 decades, we've had to invent a lot of that ourselves, and quite frankly, that is not our core competency. Our core competency is the domain expertise, and so we bring in key partners, not many, but a few that are really important to us, and Microsoft's a big one that helps us actually scale this out. And we'll talk a little bit about why that partnership, but ultimately what it comes down to is some common beliefs on focusing on customer goals and on customer first and being kind of innovators and driving that, Microsoft in its space and then us kind of in ours. So I'm going to walk through 3 real quick examples where we're really doing this. So this is not kind of all hypothetical. I just wanted you to understand big, hairy, nasty problem, and then what do we do about it? So we'll talk, actually real quick, so the 3 we're going to talk about: network disruption, blockchain, and mixed reality. We'll talk those 3 use cases. So the network disruption one. So when you travel, when there's a disruption, let's say that there is a storm in Atlanta. Storm's going to happen, that's going to impact Atlanta. If I have to close Atlanta or reduce the flow rate, meaning if you measure an airport by how many the maximum number of planes that can get in and out per minute kind of thing as a flow rate, if I have to reduce that by 50% for the day for this particular event, that's going to impact about 36,000 people, and it's going to cost the airlines about $16 million. So it's a non-trivial thing, right? And what happens is, if just your one flight is delayed, when your flight's delayed, they have to figure out, okay, you know, what do I do with these people? Do I get a new plane? Do I put them on other flights? Do I wait for the part and fix it? Like, they have to make those decisions, and they have to balance those decisions across the entire network of cascaded events that occur. So if I do that in a maximum, like an event like a storm, that could have impacts. I make that one decision on that one flight, I have to make that for hundreds of flights, and that will actually take days to resolve through the network. It's a huge, huge, huge deal. And so what we do is we actually bring all those different systems, because it takes them, by the way, a year to plan for that day of flight, a year. So they plan for a year. Imagine you plan for a year, like for your wedding, and with the guarantee that it's not going to go right. You know there is no such thing as a perfect fly day. Something's going to not work. So they plan for a year knowing something's going to go wrong on that day, and they're going to have to fix it. That data, like I said, lives in all these little silos. What we do is we use OR, we use ML and AI, we build algorithms, and we build solvers. We pull all that data from all the different sources. We let them prioritize. So do you want to prioritize on-time performance? Do you want to prioritize cost? Do you want to prioritize passenger reaching their destination? So for example, if this event was occurring near the holidays, you know what? We don't care if the flights leave on time. We're getting everybody home, right? So that's the pivot. And then we give them some options, and we do that in seconds. We literally can run all those things. We can even forecast models forward, and we can give them all those options in seconds, and then they can say, that's the one I want to run, and it executes, pushes back down into the systems of record, and makes all those changes. All of the products we build, because we focus on the modeling and forecasting, we then show the options, and we solve crew and everything, because when you swap anything or you change anything, you then have to look at, okay, well, do I have crew who can fly it? Or do they meet the rest requirements? There's so many rules. I can't even tell you. It's amazing how many rules you have to follow to make this all work, and we do that in seconds. And we deliver them those options and let them execute those. The scaling is what Azure gives us and the rapid deployment. Our ability to deploy that quickly, to integrate the customer's data very quickly, to do that across all of those different silos of data, and to get that thing back rapidly is all stuff that we get when leveraging Azure as the underlying technology. So now let's talk about, okay, so I do have a plane that's out for service. We'll say it's out for service as a planned event, right? So planes, just like cars, you've got to send them in for an oil change or for, you know, the 30,000-mile checkup or whatever. Planes have to do the same thing. Imagine, though, if I send my patient to the hospital and I cut the person up into a bunch of pieces and I send each piece off to the different specialist. That's basically what happens with a plane. So a plane comes into a big MRO like MTU. They take that plane, they break it all down, they send the engines to us, they send things all over the place. Those people then that are specialized, they take their part and they break it down even more into more and more pieces, and they do the service. And then they put it all back together and they test it and they send it back and it gets put back together and tested and so on. There's a huge amount of paper that has to get tracked. I mean, it's massive. So you've got all these different operators that are all touching different parts of this, that are all making paper, and somehow Delta Airlines or whoever, when they get that back, have to know that all the work was done the right way and have all that documentation, or they can't fly the plane. So we're doing a proof of concept with Microsoft and internally and with MTU to basically create chains and do all that on blockchain. So we can take the exact same process that exists today, but take massive amounts of time out, massive amounts of lost time, lost opportunity, waste, paperwork, and so on, and just eliminate it. And have an immutable single source of truth that's defensible. So that's a powerful, powerful use case. The final use case that I'll walk through is then the engine itself as an example. So you guys are all big fans of aviation, I know, and so you follow things like the Paris Air Show religiously. You can't wait to see what GE is going to announce and so on, I know. So you all know that at the Paris Air Show this year, we rolled out a brand new engine, the most powerful engine in the world. It's an amazing thing, an amazing thing. You guys have flown on 737s before, or like an Airbus, okay? So you know how wide that plane is, right? So you know, you've got 3 seats here in an aisle and 3 seats there. This engine is as wide as the fuselage of the plane. It's that big. Each one of them costs about $25, $30 million. So you can imagine we don't have spares just like laying around. Like, oh yeah, we got one of those, we'll send it to you. Like, no, that's not how it works. So if I've got a bunch of mechanics who are highly specialized that need to know how to use this thing, and I don't have a bunch of planes, by the way, can you imagine shipping one of those? Like, I'm going to send you one. How do I send it to you? It's like you need like a very special aircraft just to move it. So we don't fly these things around. We don't do that. So for you to get a chance to touch one of these is a rare event. And then the first time you see one, to be able to diagnose it and actually get in and fix it, well, you've never seen one before. So using, basically using augmented reality, using things like guides and HoloLens, we're doing tests where we're basically simulating the engines for training and allowing people to see the engine, walk around the engine, effectively touch the engine, and then using guides to help them resolve things on an engine they've never seen before, because there is a lot of newness in these engines. So that's another use case that we're running. So those are 3 real things. They're using Microsoft technology, they're using our expertise, and they're actually bringing material real gains back to these enterprises and trying to reduce that complexity and allow them to do things safer, better, faster. And with that, I'm going to bring the pilot back up to land this plane.
Yeah, actually, my first career, I was a pilot, though, so this is kind of full circle for me. So I went from flying jets in the Navy to into IT and then back to aviation. So it's been an interesting interesting journey for us, and for me in particular. couple summary slides. There's a lot of things going, and the term digital transformation, it could be the most overused consulting, Amber Alert's still going off, overused term I've seen in any industry. And a lot of it is, if you look at the basics of it, it's basically what we used to call BPR a long time ago, business process reengineering. The fact that we can do things with data today that we didn't be able to used to afford to do in the past is really what's causing the transformation to really happen, though. If you looked, I had to deal with a petabyte of structured data and build queries and analysis off that, you couldn't really afford to do it for many use cases. And the amount of data, amount of data that we say machine-to-machine data, if you look at, Sean talked about those 10,000 flights. Today we do a lot of sample sets on some of those engines. We do a lot of snapshot data today, so we don't do the full recording. We're getting to this point where we're going to record every event that happens on that aircraft and be able to analyze it. Now, it's not data you want to keep forever. You want to look at it, look for trends, you look for anomalies, and then you catalog it and build metadata. So we're using a lot of the technologies that are inherent in the Azure stack to actually allow us to process data that we couldn't afford to do 5 to 8 years ago. So that's really what's happening. And you get into the airlines in particular, they're in different states, depending on, a lot of it is how old is the airline, how long have they been around, how much legacy infrastructure do they have. They tend to be fairly siloed still. They're getting to the point where they're starting to share data across the different organizations, but the maintenance guys don't necessarily share data with the safety guys, and safety guys don't necessarily share, and there's a lot of regulations. We have pilot data. We had to get the pilot unions to actually sign off on allowing us to look at how a plane actually flew. We have a product called Flight Pulse that looks at, the pilots can actually go and look at how they flew versus their flight plan, where they could have saved money, and so we start cataloging this data. 5 to 8 years ago, we couldn't have done that. There wasn't enough infrastructure available at a price point that was reasonable enough for us to do that. So that's what's going on, and I think this is going to be going on for a long time. I think some airlines are going to be fairly innovative. We tend to look for kind of fast-moving customers that are doing something very innovative, and then see where that's going to adopt. Who are the kind of the laggards, the followers are going to be adopting those things down the road. So there's a lot going on in that space. On the digital transformation, one of the things about GE, we do have a fair amount of credibility is, we're actually exporting a lot of our learnings to our customers. We had to do it internally to optimize our own infrastructure. When you make the engines we make and you make the businesses we're in, we have to get more efficient. We have to do turnaround times. We have to increase our supply chain is very complex. And how do we actually deal with all these suppliers and integrate? So we're starting to learn how to capture all of that data to make better business decisions. But then we have credibility when we go out and talk to customers and say, yeah, we've done this internally. This is how you should look at it. We built our own data lake, and we have all these models. We have more than 3,000 different algorithms that we've built within our engineering teams that look at data sets and draw conclusions from them. That goes back to why this partnership really makes a lot of sense for us. Like Sean mentioned earlier, we're not, if you think about, I want to start a software company. Anyone can really start a software company, but you have to have domain expertise. You have to have knowledge. One of the things we have is the physics knowledge. If you look at our Global Research Center, which is also working with Microsoft, they know how things were built. They know the materials actually went into the turbine blades. They know how the composite materials. So we have all that physical science we can apply, as well as the statistical data modeling side. Leveraging the Azure stack allows us to scale and really focus on what we're good at doing. And not get into, I don't need people that know how file systems work. I don't need people who know how virtual machines work. I need people that actually understand the data that we're gathering and how to analyze that data. And so that it was a very natural partnership, relationship to proceed with going forward. So there was a lot went into that decision, but I can say 2 years into the journey, I think it's been Microsoft's been a great partner for us. They've supported us. They've trained us on how to use their tool sets. I challenged my engineering team to get 300% more efficient in 3 years. That was their target. They had to get, so the same engineers have to write 3 times as much code 3 years in, and they're 2 years into that journey now, and they're actually starting to hit those numbers. Lastly, we really talk about what are the opportunities out there. There's a lot of inefficiencies in the airlines, and we categorize some of that. We look what are the digital opportunities there. There are 2 measures, well, 3 measures we really look at when we're talking to an airline. They call RASM and CASM, and then time on wing. RASM is revenue per average seat mile. That's something, if you look at a airline puts out their financials, you'll see that term mentioned, and they're looking at how much revenue can they get per seat. CASM is cost per average seat mile. So you really have to look at, and you look at the cost of an airline, there's obviously a large capital cost that is called the planes, but the people and fuel are the variable costs that you really have to optimize. And how do you optimize that more efficiently? I'll give you an example. I was in India 2 months ago, and we started talking to some of these, Indigo was one of our customers. They announced a $21 billion jet engine business deal with us in Paris. They've doubled the size of their airline in the last 5 years, and they're going to double it again in the next 4 years. And you look at where they fly, it's all inside of India, and they're turning 7 turns a day on these aircraft. So it's all short hauls, 1 to 4 hour flights max, 7 turns a day. That's a business problem that really needs, and they're growing it 20% a year. There's a whole litany of things that they're experiencing that we can actually apply our technologies and our platforms to actually go to help them address. So I've just given you a little bit of context of what is going on in the world. A short haul carrier is different than a long haul carrier. So we have to look at how do we actually optimize for both, and we're doing that in the industry. I did want to close up. We'll open up for some questions. I think we're going to have like 10 minutes left over for questions. But I do want to thank Microsoft for inviting us here and let us get on stage and talk about the partnership, talk about what we're trying to do in the industry. I do think it's a very palatable story, and I want to thank them again for winning the JEDI, the Defense Department Cloud Platform, because we bet on that 2 years ago, and it's turned out to be a good call for us. On that, I'm going to thank you and open it up for any questions. Does anyone have anything?
So I'm just curious, architecture. So you've got upwards of tens of thousands of sensors per second.
Right.
So that data is somehow networked to something on the plane. Architecturally, give me an idea of what that is, and then where's Azure Stack actually deployed, and what's the integration link to that?
Yeah, so effectively what happens is all these sensors flow onto a bus on the aircraft. So the
You mind me asking, I used to work with GE Aviation, so I came out of the factory.
Yeah, so the bus basically has its own proprietary protocol that all the airline manufacturers adhere to. They pre-install that, so that infrastructure exists on the plane, and then everything kind of plugs into it. So it's a backbone on the plane itself. So everything from the cockpit and avionics to the cabin systems, Wi-Fi on board, all of that stuff kind of feeds into that, and then it's got a kind of different secure zones and unsecure zones and so on. And then what ends up happening, so just getting into the connected aircraft story, then what we try to do is we use things, we have a thing we refer to as a data concentrator, where we capture a lot of that data, and we actually compress it and hold it. When you then pipe that off the plane, traditionally, you're going to send that off using radio, which VHF, which is really expensive. Yeah, it's super expensive and super slow, so you can't really do it. Or you're using legacy satellites, right? So you're using Inmarsat or Iridium or something like that. Again, not the cheapest solutions in the world. And then what would end up happening is then when the planes would land, that would be it, and the logs would wrap and you'd lose the data. Or maybe you could run somebody out with a cable and plug it in, like a giant LAN cable, and plug it into the, or you rip a drive out and you put a new drive in if you really care, or something like that. Then they transition to Wi-Fi and cellular, but the problem with that is you probably don't have enough bandwidth, and if you think about most planes are only on the ground for about 45 minutes from wheels down to wheels up. They're at the apron for 15 or 20 maybe, right? So, or 30. If you're really stretching it out, right? So on these high turns, you're not getting that data. The other thing is a lot of these legacy systems would talk to a proprietary ground network. So if I'm an airline, I've got my own radio towers, and I'm collecting my data directly from my planes to there. So when we talk about this Bombardier example, we've kind of flipped all that. Now, the data concentrator collecting all the data, that can then bandwidth shape, so it basically can do onboard analytics. So it not only compresses the data, it can derive so whats. It can use things like cellular or SAT it will be 5G at some point going forward, and so on. And then that goes into a ground network, which is basically cloud running on Azure, and Microsoft is backhauling that data all over the world for us, right? So it's still. So we're not using Stack in that case. We're basically running the application, and then that's pushing straight to Azure Cloud. So edge computing, we're starting to look at how we would integrate their edge into what we're doing, more for manageability and deployment and those sorts of things. But we actually already have our own partitions. But managing those partitions and updating them and telemetry and all that, we think there's a big play for Azure Edge there. We are doing that today, yes. But we're unique there. That's actually not something that like our competitors do. They don't run analytics on the plane. They just capture data, or they don't even capture the data. They're just capturing safety events. We're doing all of it. We're capturing safety. We're capturing raw data. We're doing analytics. We're deriving so whats. We're pushing those down. Yeah. Thanks for the question. It's good.
Long answer.
Any other questions?
Okay, that was easy. Easy audience. All right, well, thank you very much.
Thank you guys so much.